Welcome. In this video I want to show you how to implement an online store complete with a shopping cart and a checkout powered by Stripe. So this will give you an idea of the basics and then you can adapt it for your own purposes. Let me give you a demo. There is a manage product interface that normally should be open only to the shop owner. You can go there, and I implemented a modify in place interface so that you can change the quantities, upload new photographs, and change the details, remove some products, and so these you can use as an example if you like of a fully editable grid. There is no protection now, so it's not even required to log in. Obviously, if you were going to deploy these in a production application, you would have to check that only the owner is authorized to access this page. For example, checking that the email of the currently logged in user matches some predefined email. I didn't put any security because I wanted to give you a bare bones example of the code that then you can adapt to your own application. Okay, so the main page is store, which is also the index page. It loads some products. It has a search bar, so if we write Ted, we end up only with a teddy bear. And if we say Be, we end up also with a duck because Rubber BE is contained in rubber. Okay, so I search both in the name and in the product description. But aside from these, you can clear the search. You can choose, for example, to put in your shopping cart 2 teddy bears, 1 rubber duck, and 1 cowboy hat. No, why 1? Let's put 3, okay? Well, 3 is too many. 2 is fine. And once you have these in your cart, you can go look at the cart. You can do all this without logging in. So you can look at your cart, okay? You can continue shopping. If you refresh the page, your cart is not lost. I will tell you later where it is stored. It is stored in local storage, so you can have a persistent cart even though you're not logged in. It's not in the session actually. Once you are ready, you can examine your cart. Okay, and there is a button checkout, so you can initiate the checkout process. I ask for shipping information. You can ask obviously for more information if you wish. I can put here like Luca de Alfaro and UC Santa Cruz. It will never get to me this way, but it doesn't matter. And when I click pay, this will redirect me to Stripe to complete the checkout process and enter the credit card information. So I can click here. The Stripe page will load. It gives me, look at the Alfaro instructional store in test mode. I'm not using real transactions, obviously. This is how much I have to pay it. Here is a listing of the products. This is the cost of each product. Then there is a total, right, that I have to pay. And because we are in test mode, we can enter a fake credit card. No, sorry, this is email. So look at ucsc.edu. And then I can edit for 2 for 2, for 2 for 2, for 2 for 2, for 2 for 2, 1, 2, 23, but anything in the future. So this number, you have to use this number. There are 3 numbers that Stripe accepts. There is one that is accepted, one is declined, and the other one that is, I think, fraud suspected. Okay, but the for 2 is the one that is accepted. So we can put any CVC, it's not verified, the name on the card is Luca de Alfaro. Zip code is 94040, no, is 95064. And I can click on pay, this processes the payment, checks it, and then I could redirect it to a better page. But I redirected it to the original page with an empty cart and with the product in stock that have decreased because, the ones that I bought and put in my cart are now reserved for me. So this is the basic setting, and now I want to show you the various pieces of the code that go into making these. Once the payment happens, you can also look at the orders. Here I write the order date, Then the ordered items, which is product ID 1, product ID 2, product ID 6. There is a fulfillment information, which is what I put. Created on, paid on, and there is a flag, boolean flag, that says it has been paid. Again, this is not a fantastic format, but you can adapt it to whatever backend you want. So this is how the app works quickly, and now I want to tell you how the code is implemented. So let us look first at the Manage Product page. So let us look first, in fact, at how I obtained this menu. This menu is obtained by modifying in the layout this section, which is the menu items that you can put at the beginning. You know, there are two menu items. There are the initial ones that go to the left, and then the nav bar end ones that go to the right and contain the login portion. So I added elements to the menu bar by adding links over here to the layout. This ensures that the same links are present in every page, and they have a top bar with a homogeneous style. Now for the Manage Product page. This is essentially a table that I put out, in which I can toggle an attribute of every element of the table, of every cell, between clean and edit. These are the two states. If it's clean, it displays as if it's in read-only mode, and if I click on it, it switches to edit mode, and then I can edit in place. Okay, so that's the method. This is very similar to what we did in a previous lecture, in which I taught you how to modify contacts by clicking place and updating them in place. So so the only thing that I do here is that I have actually arrays to control both the rows but also the columns to avoid repeating too much code. So if you look at the code, it's actually quite compact. In Manage Products, I have, generally speaking, you can look at the details, but there is some code to deal with the upload. Okay, this is the upload button, and this is the image. Okay, and then there is a loop. So the whole fields of the table is done between these lines, between, you know, this TD tag and its closure here. That's where all the action is that produces all the rest of the table, because I iterate over the rows, but also I iterate over the fields so that I don't have to repeat code. And you can see that I have these if then else's according to whether the state is edit or clean. Clean is for when it's read-only, and edit is when it's editable. Okay, and I listen to the various events on when I click and when I blur. When I click, I switch the state to edit, and when I blur, I store the value and send it to the server. So that's what makes that grid happen. Then there is a delete button that I have. Again, is not very special, and there is a button to add the product that is based on having some region at the top of the form where we can add a new product. So this is all fairly standard. It's powered by some JavaScript that is fairly compact and is fairly similar to the JavaScript we saw in the contacts lesson. So I'll let you look at it and won't go into the details at all. In the controller, there is some code at the end that deals with this. You see, there is delete product, edit product, upload image. There are very simple methods that serve essentially the purpose of storing an individual piece of information, and so on and so forth. So this is a page that I think is useful to as a model to build many similar pages, but the real action happens in the store page. The store page incorporates a couple of interesting tricks. One is this. Let me put something in the cart. So I put 3 teddy bears and 4 ducks. Okay, so now I can go to the cart, and now I can continue shopping. Now I can go to the cart and continue shopping. But you see, the URL is always the same. So here I'm essentially pretending that I have 2 very different pages. The product page, in which I can search products, I can look, I have only 3 here, but potentially I could have very many, and I could have a nicely implemented search. Okay, and the cart page that instead tells me what I have in the cart and gives me the checkout button. So I have two pages logically, but I can switch from one to the other as in an app that looks like a single page app. The method I use is actually very simple. It's visible here in index.html. For instance, here I have this VUIF page is equal to prod. I have essentially two names that this variable page can have. One is prod and the other one is cart. And if the page is prod, I display the main content page of the products and all the things you see in this page essentially. Sorry, here we are in the cart. In this page I meant. And if you are instead in the cart, the value of the page is cart and it will be displaying some other content entirely. You see there is a VUIF page is equal to cart. The continue shopping button is implemented using a goTo function. This goTo function simply sets the value of the page variable. You can see it here. And so this gives me a very simple way of having an application that is a single page app that essentially simulates multiple pages. Obviously the back button of the browser doesn't work, but all the rest works. So the next point is, where do we store the cart? You have seen that if I put something in the cart, for example 2 teddy bears, if I reload the page, the teddy bears are still in the cart. So where do I store it? There are in general two choices. One would be to store it in the session on the server. The advantage of this is that as the website owners, we could run an analysis of what people have in their carts at any given time. But here I chose another solution. I'm going to store these into local storage. Local storage is essentially a dictionary from strings to strings that is unique to each host name and port combination. So this is implemented as follows. Because we can serve multiple apps from the same server, the controller will pass the name of the app into this variable. In the index, I take the name of the app and put it into an app name, and in index.js I have a code here that stores and reads the cart. Sorry, let me remove this highlight. Storing the cart is quite easy. I say local storage for this app name. This is done in order so that multiple apps can coexist if we use the same convention. And so the local storage for this app is going to be the translation to JSON of a dictionary that says cart app vu cart. Okay, I do it in this way so that I can store not only the cart but also other things if I so wish. Conversely, when I read from local storage, the key line is this one. So the cart is going to be JSON parse of the local storage for the current app, and then I take the cart component. So I exactly undo this statement here. I have to be careful to catch the errors, because it can always be the case that what you put in local storage was due to an earlier version of the code, perhaps, or simply the local storage was empty, and so you need to be able to recover from the fact that it's not in a state that you expect. Putting things in the cart is implemented via the byProduct function, which is a lot of code but is really quite simple. What it really does is that it checks whether the product is already in the cart. If it's already in the cart, then it increments the quantity, and if it's not in the cart, then it adds it to the cart. So this is quite simple, and after that I update the cart to essentially make it consistent, and I store the cart in local storage. So the application can be in two states: the checkout state, which is the initial one, and the pay state, which is the one in which you go when you fill in your fulfillment information. When you are in the checkout state, there is a checkout button, and when you press it, you go into pay mode, and the function that is called is this checkout function that you can see here in the JavaScript. What this does is the following. It actually contacts the server to check that the products you actually want to buy are still available. Okay? So this is just a safety check. There could be multiple people buying from the store. I don't want you to fill in all the shipping information if in the meantime the product is no longer available. And so I contact the server, I get the answer. If the server tells me that it's okay, then I go to checkout state pay and I display, you know, these form where you can enter the fulfillment information. If it's not okay, what you really should be doing is something smart. For example, you should give back some information. This is a product we could not find. We removed it from your cart. You can add additional products if you wish, or you can, these are the replacement that we advise you to buy. You can give them advice, purchasing advice, whatever you want. So the sophisticated solution can be implemented to your pleasure. What I have done here is implemented a very simple solution in which I tell you, I'm sorry, somebody else bought it before you did, and I simply empty the cart, the whole cart. Clearly there are better solutions that you can adopt. This is a very brutal one, but notice that this will be triggered only if somebody else has bought the product in the time, between when you put it in the cart and you click on checkout. So it's not a very frequent occurrence, but it can happen. So here you enter your information, and when you click on the pay button, you trigger the payment part. And this is actually the interesting part, where the action happens with Stripe. To implement this part, what I had to do is I had to go to the Stripe API reference. Actually, I had to go to Stripe in general and create an account for myself. That I created the Luca educational account. And I downloaded a key pair that I put here in a private folder, Stripe keys. And there are testing and production keys of Stripe. If you use the testing keys, you use these mock transactions that you have seen that do not carry any monetary consequence. Then, once you are ready for your shop to be actually deployed, you need to apply for production keys. Applying for production keys is slightly more complicated. You need to provide your company EIN or your own social security number. You need to connect it to a bank account. Stripe will run some verification on you. It will verify, I don't know if they check your credit report, but they will verify that the bank account is actually tied to you. And so there is this little bit of verification going on, right? Because there is real money changing hands. Stripe, I believe, reports what you get through the store to the IRS. You need to declare it in the taxes and so on and so forth, okay? So to obtain production keys is more complicated, but Stripe gives you freely development keys that you can use to develop your code. And those go into these Stripe keys. You can see here on the server in controllers.py that I actually read these into something called Stripe key info, and then I have the test private key that I use on the server to assign to my API key of the Stripe object. Okay, and instead to the client, to the browser, I give the test public key that will be stored in a variable called Stripe key. If you go here, you can see it, Stripe key. Okay, so there is a public key that goes to the browser, which is called public because any user can view it in their own browser. And then there is the private key pair that stays on the server, and that should not be leaked. Okay, so you should be careful that these things are not added to Git, obviously. Now, Stripe has a very good documentation. There is a Stripe API reference, and there are various methods of payment. So the one I have implemented is the Stripe checkout. You can look at the overview, and you can also look at a sample integration that is actually quite helpful for you to design the code. So this is highly recommended that you look at it. So let me give you here a little animation of what happens when you want to pay. What happens is that you press on the pay button, and you let the server know that the user wants to pay. At this point, the server will contact Stripe, and it will give it what you want to buy. Okay, so what? You give it a description of the items and their cost, and you receive back a session ID. Once you have this session ID, this is like an identifier of the purchase you want to do. This session ID is given back to the shop, okay? Session ID, I write simply. Now, you use your JavaScript to redirect to Stripe. This is a redirection, okay? A redirection to Stripe that contains this session ID so that Stripe knows what the user is trying to pay for, okay? Then you go to this web page that is served from the Stripe server, okay? And here the user enters, their name, their credit card information, their whatever, and there is this button in the end that says pay, really charge my credit card, okay? Once this happens, once the user clicks on pay, this redirects you to one of two pages, okay? There is a success page and there is a failure page. And so you have to handle these two types of redirect, that will obviously load pages from your server. This lets you know that it went through, and this lets you know that it failed, okay? And the transaction is done in this way for the following reason. Actually, there are multiple reasons. One is as follows. Once the shop tells you that they want to pay, you can privately tell to Stripe exactly how much the user wants to pay. This is important. The command that charges the actual amount of money has to come from the server, because otherwise the user, if it was the browser directly telling Stripe how much to pay, the user could possibly tamper with that information and say that the price to be paid for the same products is lower. So it's important that the what and the price actually comes from the server, okay? You get a session ID back, and then there is the other part of the trick, that is the shop redirects you to Stripe using that very same session ID. This accomplishes two things. The obvious one is that Stripe will know how much to charge you, right? Because this session ID here is the same that you passed there. The other not so obvious one at first, but fundamental to the working of the transaction is this. You never enter credit card information on your actual store. The credit card information is only entered on Stripe. This is because to become a credit card processor, so to become a company that can actually handle credit card information, is a very high bar to pass. You need to have a certain number of legal constraints, you have to go under regular audits. So I do not know exactly how much that costs in terms of audits, lawyers, regulations, and other requirements, but it's on the order of $50,000, give or take. It depends on which lawyers you hire and how you do the audits and how you do the process, but there is a high bar to pass. Not only, it is a bar that you may not want to pass, because if you pass that bar, then you are processing credit card information in your company, and then you become a much juicier target for any hacker that can try to then steal your credit card information, right? This raises dramatically your security costs, because then you have to do much better audits on a regular basis, much better code audits, much better security, much better everything. So if you can avoid touching credit card information, it is much better. And what Stripe allows you to do is precisely avoid touching it. The user enters the credit card information on the Stripe site. Stripe will verify the transaction, and then it will do this redirection to the success or failure page. But you are never given the credit card information of the user. You are simply told, yes, the user actually has paid you, or no, the user has not paid you. In fact, I should say that there are two ways in which you can be notified of the success of the transaction. The one we are using here is a bit of a simplified way that I did because our site is not really deployed in the cloud. The better way to be notified is actually that Stripe, if you so ask it, can do what is called a webhook, which is a callback from Stripe to your server. It's as if Stripe is hitting your own API to tell you whether this went through or not. Okay, so this webhook call is a better way to be notified that the payment went through. Okay, because because it's directly from the Stripe server. We're using here a way that, as far as I know, is equally secure, but it's slightly more based on a redirect of the user browser, which is not as good as being told by the server. Various things could happen here. The user browser could die during the redirect, or other stuff could happen, so that maybe the user still has paid, but you don't know it. The webhook is really the guarantee from Stripe that the thing went through. The only problem is that we cannot use a webhook in this example, because the webhook needs for your code to be hosted somewhere for that to work. So I will not give you an example of that, but there is very good documentation in the Stripe API reference about how these webhooks actually work. Is somewhere. There is a billing, connect, notifications. It's somewhere in here you can find about the webhooks. Okay. So now let us go to the implementation of this little dance. The little dance begins with 1, I want to pay, 2, I get a session ID, and 3, I redirect to that session ID, okay, and then 4, I have to intercept. This from the point of view of the browser. And the server, when it gets the signal that you want to pay, it has to tell Stripe and get the session ID. So let's see how this little dance works. So here is where the dance becomes. I have these app items that I have actually set when you press the checkout button. But when you want to pay, I have these app items that contains the identity of the items you want to buy. And I have the fulfillment information that you have just completed in the form. This is your shipping address in our case. And you post this to the server. You send this to the server, and what you expect is for the server to give you back an OK and the session ID, or perhaps a failure, because again, the purchase cannot be completed, because this time while you were filling in the fulfillment information, somebody else bought the products. Okay? So this will be by far the most common case, the one in which the products are still available and you got a session ID. So you see I get a session ID from the response data, I store it, and then I obtain a Stripe object from this Stripe library using the Stripe key, and I say stripe.redirect to checkout to the session ID you indicated. And once this comes back, I essentially say that the transaction worked. So this Stripe library here, this capital Stripe, is the Stripe library object, and it is loaded in index.html via this line here, this script line here. Okay, I loaded the library from jsstripe.com version 3 of the library. So the part on the browser is actually quite simple. To recap, I ask the server for the session ID, sending the items I want to buy and the fulfillment information, and the server replies back with a session ID. I use the session ID to redirect the Stripe to the checkout session. That's all it happens. So it's quite simple. Now let's look at what happens on the server. On the server, I created 2 tables. One is the product table, obviously, that holds the products, but the other one is the orders table that contains the details on the items, as we have seen, the fulfillment, and also crucially whether the thing has been paid. Because when you tell me what you want to buy and I reply with a session ID, I do not know yet that the thing is paid. In fact, it's not paid until I get the redirect. So on the controller, it works as follows. There is this method that is called pay. And I do like this. I get the items and I get the fulfillment information. Then I need to build, and you can read the code for yourself, but I need to build these line items that are used by Stripe to display as a confirmation to the customer what the customer is paying for. Okay? So here there is a certain format. Unfortunately, I cannot include images as image URLs, but if you had real image URLs that are normal URLs and not data URLs, you could include them. And so you could generate a nice looking image of what the user is about to pay. Remember also that the prices are in cents, If you use USD as a currency, you can, Stripe accepts payments in any currencies, so you can change also your due amount to be in other things than USD, for example, euros. And once you prepare these, this is your way to tell Stripe what the user is paying for. And what you do is that you write it in the database. Okay, I insert it in this customer order database to remember, okay, this is what the user wants to buy. Okay, and I get an order ID. This is what the user is trying to buy, and I get an order ID. And then I create a Stripe session via the Stripe library, Stripe checkout sessions create. And I give the payment method types that are accepted, in this case only credit card, but you can add other payment methods. I specify the line items that I want to buy. The mode is payment, because I want a payment. And then I specify 2 redirect URLs in case of success and in case of cancellation or failure. Okay? And my URLs, I make them signed, so I know that there cannot be any spoofing. And essentially, I encode the successful payment or the cancellation of the payment for that particular order ID that I created. So in this way, I will have the confirmation of whether the order I have inserted, which originally is marked as not paid, will actually be paid. And I will reply to the browser with OK and also with a Stripe session ID. One word about this Stripe library, you obviously need to install it, and it's called unsurprisingly Stripe, so you need to do pip install Stripe, and if you were to deploy this on the web, on the cloud, you would have to add it to your requirements.txt. Otherwise it's not present, obviously. So let's look again at the controllers. What happens? These are the 2 redirect URLs to success and failure. Let's see what we do. If the payment is successful, you see here I marked that really we should use a webhook, but this is a poor man's solution that works even if we are not deployed yet. What we do is this: we fish out the order because we know the order ID, and we essentially say that the order is paid, and we also mark when it was paid. If instead the payment was cancelled, what we do is that we delete the order from the database, because we don't want to track it, right? The payment has failed. Maybe simply the user wants to go back and add products, so we don't know, but the customer order entry will be deleted. And so this is all of it. There is not really a lot of it that happens. Again, there is this little dance in which we create line items. We create a Stripe session so that Stripe will know what the user will try to pay for. We retrieve the session ID and we pass it back to the browser. And then on the browser, the crucial place is this redirection to checkout, in which we cite the same session ID, so that when the user is redirected to the checkout, Stripe can display what the user is trying to buy and can provide the proper price. Okay, so that's it. If you are gonna do this for real, obviously you should get information about taxes, information about liability. You should read the documentation that the Stripe API has on fraud, on other things. One thing that I can tell you as a user is that the Stripe API is quite pleasant, and so is also their website. For instance, if you need to refund a customer because, for instance, they changed their mind on the order, Stripe provides you a fairly nice web interface in which you can go and you can click on refund the customer. It gives you a very nice a dashboard in which you can see how much money is coming in on a regular basis, and the management tools are in general very good. You should, however, understand that this is a real business operation, so you may want to incorporate a limited liability corporation or something else to protect yourself from lawsuits and do all the rest that is needed. So here I essentially have given you the technical basis, but you should also investigate obviously the legal one and the tax one for doing this.